First, about the main definition of the database, and DBMS. Actually, I prepared the first quiz today, but I do not have probably time. So if we have a time today, I'm going to have a very short quiz. But I believe that you guys already understand what is the information, what is the data, what is the database, and what is DBMS system. Okay? So from now on, we are going to start. We don't have a chair. So Ahmed, why don't you help with that? So if there is any empty class, the room, bring the chairs. Very much. Yes. Based on the knowledge regarding to the definition, I think you are ready to start the database design. So this diagram shows everything that you need to learn throughout the semester, then that you need to do in your project. Okay. So first,
I missed the class.
Oh yeah, you can take. Because of that, we do not have enough seat. Okay. Because some of the students coming from the morning class, yeah, the problem. So as a prerequisite of this class, you probably took the CS390 or CS400 relating to the programming, right? In your programming class, probably you learned about something kind of the software engineering. You need to design and model your application program. Then at that time, you analyze your programming requirements. For example, sum of 1 to 10. Okay, you need to understand, right, what variable you need to sum up 1 to 10 and how you can sum up. You can use just 1 plus 2 plus 3 plus, or you can use a for loop, you can use a while loop, you can get the input for the largest number or whatever. Okay, you need to design, then implement it. That is the process, software engineering, or the software design, or the implementation of the application program. In your handout is on the left-hand side. Functional requirement, sum of 1 to 10. Then you need to analyze what variable we need, how we can sum up 1 to 10. Somebody can sum up 1 plus 2 plus 3. Somebody can use the for loop, somebody use the while loop, somebody use a different way. Okay? Then you need decide something specification in terms of transaction. Sometimes you don't need such a thing, and you need to design application program in your programming class. Until you take this class, you probably did this kind of process. Okay. However, in this class, this is the database design. Final product is not just the application program, but that application program use what? Huge, very large data. I know sometimes without using DBMS it's possible to use to manage the data, but usually they are very small. You can handle such a data like the 1 through 10. It's not that huge. You don't have to use Oracle database to keep the 1 through 10, right? However, when you implement the 1 millions of customer management system, are you going to create 1 million the variable for each customer? No, probably it's out of memory in your program. So it's not possible, almost impossible. So we need to use different way, that is database approach. So this is the overview of database design process. In addition to traditional designing process for application program, we need to learn and add this process. It's called the data requirement, like the customer. For the customer, we need what? Name, ID, social security number, address, and so on. We need such a thing. How can we do that? You don't have to worry about it. We will learn from the chapter 7. That is the data requirement and design conceptually. Conceptual design or logical modeling. We learned about the logical modeling the last class. What is the logical modeling? We are going to design for schema, description only. You don't have to create the real database yet. conceptual design is a high level. Everybody can do that as long as you understand the data. For example, customer. Then customer, I need the customer name, customer ID, and address, and so on. I need such a thing. That is a conceptual design. In addition to that, we need employee for customer management, the customer data. Okay, that is a conceptual design. Based on that, that's the design that we can do the data model. This including the conceptual design and logical design. This is called data modeling that we are going to learn in chapter 7 and 8. Based on that, we can create a real database, a physical design. However, we are not going to consider only the database design, but we need to consider both application design and database design together. Why? Eventually, application program will use the database, right? So we cannot avoid such an application design. Only for database design, that's it. No. We think about the building house. After you build a house, what you gonna do? You need to live there, right? There is a resident. You can rent a house, or you can live in your new house, or family, or for your children. Anyway, there is a user, there is a resident. That is the purpose. So, similarly, when we learn the database design, the application program is the user, consumer. Okay, so we need to think both application design and database design simultaneously. Sometimes we don't have to worry about this part if you decide not to use database in your application, in your project, in your system. Okay? But in this class, we are going to consider mainly database design. However, this application analysis will be considered in your database design too. So that is the reason. First step, page 1. I believe you already read all the description about your project, right? If not, it's too late. You should start discuss about your project topic with your team member. If you read carefully, the first page is initiation, your project. Decide the requirement, okay? That is your basis of your project. I'm not going to ask you to build this amount of the database. No, you are going to decide your requirement. So if you decide I'm going to build online banking system management, then what can you do? What is the functionality? What is the realistic query? Without understanding DBMS, no. That's the last thing. As a customer, as a user, you can think about, you can imagine, you can design your application. Okay? That is the first step. That will be your Bible. Okay? To build your database. I'm not going to ask you, I'm not going to push, build this one. No, you are going to decide such a thing. That is a requirement, data requirement. Based on that requirement, you can design and model and build your system and implement your application program. This is the overview of database design process. Also, this is the process. This is the overview of your project, entire project. Okay? So first, as a sample database, we are going to use the company database. It's a well-known database. So if you decide to build a company database in your project, probably will be rejected by me. Okay? This is just a sample. Why don't you take a look at the second page? Somebody asks you to build a company database. Then provide such a very nice fancy description about the database. So first, the company is organized into departments. Each department has a name, number, and employee who manage the department. We keep track of the start date of department manager. A department may have several locations. It's a description. It's a requirement of your company database. Okay, actually I remove all the requirements related to functional analysis or the application design to make the database design clear. Okay, so it's only for the database design part. The second requirement is that each department controls a number of projects. Each project has a unique name, unique number, and so on. And third one is for employee, and last one is for dependent. I'd like to give the 15 seconds to read the whole requirement. Then we are going to build a company database. The first step, requirement are already done. Then the second thing is data model. These are the information. Informations are everywhere in your company or in your customer's company. Then your customer provides such a very nice description or requirement. Based on this requirement, we are going to model. We are going to make the data. Okay, what is the data? It's organized and important things. Okay, this should be organized. It's important and meaningful, and so on. So we try to find such information to make the data. There are a bunch of different ways to find such important information or organization. If you are considering the object-oriented concept, you can consider such a data as an object. So you can apply UML approach that you have probably learned in your object-oriented programming. Or if you are consider such a data or relationship as a hierarchy, like the grandparents and my parents, and under the my parents there are children, my sibling, and under me there is a hierarchical approach. So we can use such a hierarchical structure or organization to manage the data. Among them, in this class we are going to use entity relationship model. Entity relationship model mainly consider your important data as entity or relationship. What is the entity? According to the dictionary or according to general definition, entity is kind of things, right? It's not imaginary thing, or it's not vague. It's an object. Okay, it's a thing. It's a specific thing. Okay. In other words, it's an important thing. Okay. So we need to find such an entity or important thing or specific thing or object from this requirement. That is entity relationship modeling. So entity ER modeling, in short, ER modeling consists of entities, bunch of entities, and bunch of relationships. So first we try to find such an entity. So you know what is the entity? Entity, concept of entity, definition of entity, I think it's not very difficult. It's existing or real thing or the object. So we are going to find such an entity first. What can be the candidate of entities in this company database? Company requirement. Why don't you take a look at it? One. Company is organized into department. So department may be important thing. We need to keep such a information as a data. So department, also each department has a name, number, employee who manage the department. We keep track of start date. Start date of the manager. Also, department may have several locations, which means department is important information. What kind of object? So we are going to regard such a department information as A1, as an entity. So that is entity. Okay, what else? What can be the another
Projects.
project. So each department controls a number of projects. Each project has a unique name, unique number, and located at a single location, and so on. What about the next?
Employees.
Next one is actually it's obvious. I already used uppercase letter for you for your convenience. So employee. The third bullet is for. Do you get handout? No. I think I prepared only 25, but I didn't think about the student coming from the morning class, so you can download from website. So third bullet is for employee. The last one is for dependent. Those are entities. Those are data. Those are important information. That's the first step in ER modeling. You did half of them already. Right? It's easy. That's one of the benefits of using entity relationship model. Okay? Then, for each entity, for example, we decide somebody may have different opinion. Why don't we have the company as an entity? Yes, it can be doable, but company is the entire database name. So we'd better have it can be presented by the entity, including department, project, employee, and so on. So each one may have different opinion. Yeah, that's true. That's the real thing. However, in our class, we are going to use our common sense between you and me. Okay? Somebody insists on we need to have another entity for example, address. Okay? Some database have such a address entity, but here address is not important object. Instead, it can be just a description of what? Employee. Okay? So it's you guys need to so that decide which one has a good skill in the database design or modeling, which one is not. So in our class, we are going to use the common sense. Actually, in real life system, not only the common sense, your decision should be made by what? Customer request or customer's requirement or data requirement. That is the Bible, as I said. So all your process should be based on this one. For example, your assignment in your programming course. So functional requirement is a sum of 1 to 10. But I can do better than that. So I implement the multiplication 1 through 10. Okay? So it's more difficult than sum up, but it cannot be acceptable. Because the requirement is the sum of 1 through 10. But you implement 1 through multiplication of 1 through 10. So that's the same thing in database design. Even though you believe I'm better than my customer, so I believe that the address should be entity. That's important in most of the database. But if your customer does not need such an address as an entity, so you don't have to do that. It will not be used in your application program. That's just part of description of employees. Then, so first we can decide the entity. Then, each entity will be described. Okay? For example, department. Each department has a name, number, manager, starting date of him or her, and locations, right? These are the description of entity, department entity. Or, for example, project. Project has a unique name, unique number, what else? A single location. These are the description of what? Project, entity, project entity. Employee is the same, social security number, address. Each entity usually has a number of description. This description is called
Conceptual.
attribute. So if you have a little bit experience on database, you may realize this description will be what? Later, this attribute will be column in the database.
Yeah, fields.
But if you do not field, it can be use the different name. So usually column or the field. Okay? But if you do not know anything about this, forget about it. We will learn and step by step. But for those who knows a little bit about database, such a description will be schema. Schema will be definition of the database table. So it's a column. So attribute. So for each entity, so employee or the department, project dependent, we are going to decide a number of attributes. Attribute is the description of an entity. For example, employee may have the name, social security number, address, sex, and birthday. Or what else? The department. Department has a name, ID or number, manager, starting date, and locations. What about dependent? Dependent has name, sex, birthday, and relationship to employee. So first step is the entity. So how many entities we find? Employee. Others. Project. And department. And employee is already there. Dependent. Then, second is attribute. For each entity, we are going to find the entity. For example, employee, it has the name and where's the employee? Yes, social security number. Others. Address. Salary. And sex. Others. And birthday. And what about the project? Project has a unique name and number and location. What about department? Department has a name and number and manager and start date of the manager and location. What about dependent? Dependent has the name, sex, EOD, and relationship to the employee. These are the first step and second step of ER modeling. First step is finding entities. And for each entity, we find what? Attribute, a set of attributes. What is the attribute? Attribute is the description of entity. Okay? Then, it's a little bit hard to recognize which one is entity, which one is. It's not well organized. So, for the presentation purpose, in ER modeling, we are going to use diagram. Like the UML diagram. Similarly, we are going to use the ER diagram. Okay? In ER diagram, first entity, we are going to use rectangle. Okay? So we can have the rectangle here, rectangle here, rectangle here, rectangle here. This is not too difficult. Then, for attribute, we are going to use over and connect to the corresponding entity. Okay, easy. So name and social security number this, address this, building this, sex this, salary this, name, number, location, name, and number, manager, starting date, and location, name. That's it. That is the output. That is more organized data, right? But still, this modeling does not depend on specific deviance. It's a high level, conceptual level modeling. It's not done yet. That is just up to the second step in ER modeling. There are several important things you need to understand. Actually, what is this? It's an entity. Entity, and attribute. So, in other words, so suppose that instead, actually, this requirement, this description, it's very easy to understand. Unfortunately, when you, after you graduate, when you involve any database, not only for the database project, real project, the customer may not ask, may not provide such a fancy, nice requirement. Instead, they will give a bunch of files, or just a regulation, or policy, or business flow. For example, in the company database, your customer will provide report for employee, like the lead, and 57 Tower View Drive, and plumber, and age is 40, actually more than that. And what else? There's a female and male, not female, and so on. Or James, and the Bridgeport, the University Avenue, Bridgeport, and 20, and Maine. Hotel, and Sylvan Avenue, and Bridgeport, and 30, and female. Sometimes your customer may provide such a report only, instead of what that is. Instead of describing withdraw employee social security number, no. They just provide such a thing. From this, these are the information about employee. Then, each of them actually called entity. There are a bunch of entities that you should realize. This entity, they have same format of information. Not HR, New York. This is different entity for department. They are different. So you can group them. A set of entity, each of them has the same format, like the name, address, city name, age, sex, and so on. Actually, each of them is called entity, and then you model. This is name, this is city address, this is the city name, this is the age, this is the sex. This is called entity type. So actually, employee, project, department, and dependent. Are they entities or entity type?
The entity types.
Actually, it's entity types. Entities are sample database or sample instances. By grouping such as same instances, you need to be able to find entity type, name, address. That is those are called as attributes. Okay. However, good news is entity type. We can use most of the database designer or the database programmer. They are using entities and entity types interchangeably. Use it mostly just simply entity. That's enough. Entity type, no, it's complicated. That's the good news. So you don't have to worry about too much. Entity is enough. Bad news is in your midterm exam, I'm going to ask what is the definition of entity type? What is the definition of entity? What is the difference between entity and entity types?
Entity type is attributes.
Yes, it's a set of attributes. Good. It's a schema. Then, actually, from these entities, you need to collect the same format of entities. Those are employee. Then you need to realize we need name, address, and so on for employee. However, if your employee provide directly this information, I need the name, I need the address, then you don't have to worry about this. Okay, this entity is an entity type. So from now on, I'm going to use simply entity instead of entity type. However, in your exam only, you need to know what is the difference. Also, one more thing. By grouping entity type and entities, we are going to call this one as entity set.
Entity set.
What is a set?
It's a group.
Set is a group of elements. So this is the clue. We are going to use this definition set to define the data in the database. That's called the relational database. We will learn later. But right now, you don't have to worry. Just call entity set, entity type, entities. So you need to know for your exam only, but from now on, I'm going to use a simply entity instead of using entity set or entity type. Okay? So here, actually, this is the entity type and attribute. Yes?
Entity set, isn't it the instance of the
Entity set include entities, instances, as well as the entity type schema. Later, it will be table later in your database. Table is entity set. Okay, table include the definition and also data, right? So it's the same. If you do not understand what I'm saying right now, what is the table and what is the data, don't worry, we will learn later. Okay, but you should know this is an entity set. Set consists of entity type and bunch of entities. But informally, from now on, I'm going to use simply entity. Okay, that is the one thing. Also, one more thing. From this, it has, for example, social security number here. 111, 222, actually 9-digit number, 333. Okay? How can you identify each entity, each person, each employee?
by a unique name?
You need to find the unique data for each entity, like the social security number. Or if there is an employee ID, just like the UB ID, you can use it. So sometimes social security number is the key to find, to identify entity or person or data or employee. That attribute is called key attribute. Okay? Key attribute is the key. As name implies, it's a key to find someone. Sometimes name can be key, sometimes not. Like in our classroom, this class does not have any duplicate name, but previous semester, I have the two Bin Lee, it's a Chinese student. Both of them have the same first name and last name. So sometimes you cannot use the name. So in this case, social security number is good. So such a key attribute can be represented by underline. What about this one? Project. What can be the key of project? Project number and project name. Why? Because, why don't you go to the second requirement? Each project has a unique name. It's too kind. Probably you will not see such a very fancy, nice and kind, generous description. Unique name and unique number. So we need select one of them. No, you can select as many key as possible in this ER model. But later it will be different story. So now just select as many key attributes as possible. So name and number. What about the department? Department, name and number. Probably company may not have the same department name, right? In the one company, that will be common sense. So you can use the name or number for the key. What about dependent? Name? Name. What if there are two J. Lee and K. Lee? He has son Nicholas Lee. He has son Nicholas Lee as a dependent. Yes, that's doable. Everybody wanna make their children's name as the good one, better one, best one, right? So there are popular names. That's true. Nicholas is a very, very popular one in the United States. Very traditional, but popular. It's my son. In that case, we cannot use the name as the key. So in this case, we do not have any key. It's okay right now. We will deal with it later. So you can find as many key attributes as possible, then underline. This is up to second step. Last thing, attribute. Let's see this one. Name. Name is just Jeongkyu Lee. But if your customer asks, I want to make the name, employee name separately by first name and last name, which means name and divide into first name, even middle name initial, last name. Yes, that is possible. At that time, if one attribute has several components, sub-component, this attribute is called composite attribute. What about the sex? It's a male or female. It cannot be composite, right? It's either male or female, or both. I'm not sure. So that is the simple attribute. However, if you decide to divide into several components, this is called composite attribute. Not all attributes can be composite. Some of them. What can be the possible composite attribute here? Address. Address is a good one. Like what? Street numbers. Street name.
City.
City name.
State
name.
Zip code.
Zip code. Country name. Planet. Okay. This is the sub-component. So, to represent such a composite attribute, we are going to use the same notation. But this time, do not connect directly to the entity. Instead, this one. So we can make kind of tree structure or hierarchy. Okay? What about the name? Name, first name, middle name, initial, last name. Any possible? I think that's pretty much enough for composite. But somebody may be curious. For the name, is this single attribute or composite attribute?
Composite.
I don't know. It depends on what?
The requirement.
Requirement. Okay, you need to decide based on this. Okay, so how can we decide it? If your application program need to access first name separately, middle name, initial separately, last name separately, you better go for composite. Otherwise, that is, if your application program access the name in a whole, one group, You don't have to separate. It's an overhead. It takes some time. Okay? Same thing in address. Like for example, when you go to the website, you need to register. When you register, sometimes address is separated by street number, street name, city name. It's a different text field. But sometimes it's one. Or sometimes two. Address one, address two. It depends on what. Their application program. They decide differently. Okay? But in our class, I try to my best to provide for example, exam. So I try to my best to provide correct, non-vague information, it's correct information or obvious information to decide either composite or the single attribute. Last thing, in this second step, up to the second step, that is, what about the first bullet for department, the last sentence. A department may have several locations. Okay? Also, if you go to the project, end of sentence description of project is located at a single location. Both of them are location. However, the first one, department, has several locations. However, while project has a single location. What is the difference? In one attribute, department have many locations. Like for example, in entity, location, this is a location. New York, San Francisco, and Dallas. However, in the entity of project, it's just a simple one, single attribute. Unfortunately, it's not easy to take care of such a multiple values in one attribute. So we are going to define another type of attribute, that is multi-valued attribute. Multi-valued attribute can have multiple values, one or more values in the database later. Not always true, but we will discuss together. For example, in this case, location of department can be several. It's a plural. So we can use double over to represent multi-value. What about the location in department? It's a department. Project. Is a multi-valued one? No. This is just a simple attribute, regular attribute. So there are three types. So after you find a set of attributes, you need to decide key attribute. Then what is the type of attribute? Among three. One is a single, regular one. Second is composite one. Is there any general rule? No. There is no general rule. You need to decide. Okay? Based on the requirement. What about the third one? Is a multi-value. For the multi-value, we are going to use the double, the over. Okay? That is up to second step. Finding entities, and then finding attribute. Okay?
Double over.
Question?
Multi-value. Use double over?
Yeah, double over. Who will see the real example? Because my handwriting is not very good. Okay, so there are three types of attributes when you decide it. So simple is the regular one. However, if you believe they should be divided into several components like the address or name, so you can use the composite attribute. The last one is a multi-value like the previous degree. For me, my previous degree are three: bachelor degree, master degree, and PhD degree. So we need to separate. Sometimes somebody may argue, why don't we have the bachelor degree attribute, master degree attribute, PhD degree? Yes, that's doable. Or you can have just simply one attribute and multi-value, because all of them are degrees. It's up to you. destroy your decision based on what? The customer requirement as well as common sense. Okay, that is a multi-value. So let's take a look at the example of the composite attribute. Even not only for the one sub-component, each sub-component may have the sub-component. Also, if you want to separate the approximate number by 3 or other locate, you can do that. That is a composite attribute. So key attribute like the social security number.
Yeah.
But somebody needs to understand the key attribute is just one. No. Sometimes no. Sometimes one. Sometimes many. Okay? Because it's a conceptual design. It's not real database yet. In the real database, it's a different story. Only one. The key attribute is required. It's called the primary key layer. Probably you heard about the primary key. Primary means primary, right? Among the keys is a primary key. So we will learn that later. If you do not understand what I'm saying right now, don't worry. We will learn. Then it can be underlined. Also entity types. Actually entity type is the entity that we design. That is the goal. We don't have to list up all the data when we design. Then what if we have 1 million entities? Are you going to list up on all the 1 million? No, probably you will not. Instead, entity type is enough. So this is an example of the car entity. To describe this is entity, one entity, second entity, third entity. All of this entity has the same format. First, the registration. Registration is a composite attribute, vehicle ID, and make, model, year, and color. Color is a multi-valued one, right? Then, this is the car entity type, including registration, vehicle ID, make, model, year, and color. Then all together is called the entity set, car entity set. However, informally, we are going to use just simply this entity, car entity. Okay? This is the ER diagram to represent this one. So we have 2 key attributes, not one key attribute combination of registration and vehicle ID. At that time, you need to connect. That's indicate one key attribute. Yes.
What is an ER design? I mean, ER, what is reason?
ER means entity relationship. We just covered entity only, just half of that. We will learn the other parts, the relationship, a little bit later. Yes.
Why do you have to share color?
This one?
Yeah,
One, as I said over here, so one is one attribute, it's a single attribute, multi. So it allows red and black. Okay? So if you believe this attribute may have multiple value in one attribute, then it's a little bit different. It's not the normal case. So to represent that, we can use the double over. Okay? It's an entity set. Okay. So initial design is like this. 4 entity, actually entity types in this diagram. Okay. However, as I said, I'm going to use just the entity simply. Employee entity, dependent entity, project entity, department entity. And employee has the key social security number. Also, work zone is the double, the over, which means many places. Okay. And also name is the composite. Also work zone is the composite. Similarly, the location is the multi-valued. In department, there are 2 key attributes. And name and number, 2 key attributes. Unfortunately, we do not have the key attribute independence. Okay, we will deal with it later. Okay, any questions so far? It's quite easy. It's not difficult. Why? Because the requirement itself is very easy to understand. In real case, it's much more complicated. Sometimes your customer does not provide any information you need to find. That is the reason in your project, you do better expertise on your database project topic. Okay? So I'm very interested in the biology, but I never read and I never took any biology course. I don't think you can implement a biological database. Okay? However, if you are interested in any specific topic, all your team members don't have to be expertise on that. So one or two can focus on such a design, and the other one will be expertise on the programming, and the last one can be expertise on database design that we are going to learn later. Okay. The next, why don't you see the requirement again? First, why don't you take a look at the first sub-bullet in employee? Okay, that is each employee works for one department but may work on several projects. Can you find any new entity here? For example,
a table named works.
How many projects?
so
A table.
each employee works for one department, like the lead works for HR department, right?
Yes.
Also, James works for payroll office, and Patrick works for administrative department. Can you find any entity?
Yeah.
Yeah.
Entity, like we can name it works. We include the attributes of the employee number, SSN, and the project primary key, which is take a look at the design.
So simply,
The name and number.
he's saying this can be the entity, right? But it's a little bit different format comparing to the last one, previous one. When we decide the entity, it's a thing. So like the department. Department can be described as the name, department number, or and so on. But this one, the lead is already identified as what? Employee entity. And HR is the entity of department. All of these are department entity. All of these are employee entity. Then this is the same thing. So we can realize this is something new kind of entity, not the traditional thing. So this is called relationship. What always works for